Alright, we working? We up? We up? Oh, we are. Get some juice. 4.7. Alright, here we go. Yeah, I'm full screen. Okay, I'm recording this on... My dog's going crazy back there. You see my dog? Right there. Like, what is she doing? That's my chair. Oh, well. I guess you gotta give up some things. So, I'm recording this on Wednesday. This will be out on January 7th, Thursday. This is 4.7 notes. January 7th, 4.7. Get it? I planned that. No, I didn't. Couple orders of business we need to get done. Just as far as you guys doing a good job getting homework into me. Some of you are just submitting answers. I've put little comments on your homework. Answers will do for this week, but this week only. When I say completion, I mean show effort. Just writing answers does nothing for me. It does nothing for you. Okay, does that make sense? I mean, you're not learning. That's the whole point. Your work should look exactly like my work. Does it need to be as clean and as pretty and as organized as a teacher's? No, absolutely not. But there should be similar steps followed. It should be pretty obvious that you watch my video and you're trying to do the problems like I did, or not like Slater is doing. Because I promise you, I'm smarter than Slater is. Okay, some of those guys that put answers up there, guys or girls, I don't know, I wouldn't trust it. A lot of you guys rely on Slater and things like that, like your life depends on it, and some of those problems are wrong. I have found multiple problems to be wrong on Slater. Alright, that's pretty much it. I don't want to teach or preach you guys. Let's just get into 4.7. You guys doing good so far. If you got any questions, we could Zoom. We could Zoom anytime you want. It doesn't matter, as long as it's during school hours. Usually I answer school messages at night too. So, I mean, there's no excuse for you guys not to contact me. You gotta contact me. We gotta be friends here. It's a team effort. This doesn't work without me. It doesn't work without you. We just gotta work as a team and get you guys past and get you guys on to whatever you want to do next. Okay? Alright, let's get into it. What are we in? 4.7? Yep, we're here. Perfect. Okay, let me flip my laptop. Are we recording? Yeah, we are. Nice. See, I'm getting good at this. Alright, so here's the deal. 4.7 is much easier than 4.6. It just is. You guys have seen this before. You saw it in quadratics and transformations. Okay, so all these should look pretty similar. Okay, you should know that this one's going to be the hardest one. We'll do that one last. I'll talk about it last. Okay, so if I'm transforming a function, that means I am stretching, shrinking, moving left to right, up or down, reflecting it over a specific axis, whatever you want to do. Okay, that's transforming. I'm moving the graph in some shape, some way, some form, right? These are the four types. Really, it's five if you count this one. If you count this one right here. But we're not going to do a whole lot of those. Okay, they're not hard. Oh, no. X or Y axis. Wrong one. Let me do this one. This one specifically, we're not going to do a whole lot of. Okay. Flipping over Y axis, I don't know. You guys get confused by it. Maybe after I explain horizontal translation, those two are pretty similar. But usually you guys get confused on flipping over Y axis too much. So we'll probably leave that off testing quizzes. I'll try to. Okay, mostly just stick to over X axis. Alright, so let's talk about each one of these. Okay, let's go from the easiest to the hardest. Okay, so I'm going to start at the bottom. Vertical stretch or shrink. Okay, so I always, last year, for those of you that had me, I explained it like Play-Doh, right? So if I have a graph, and I want to stretch that graph, I'm going to mold that Play-Doh, put it in my hands, right, and I'm going to stretch it. Vertical stretch. What happens when you stretch Play-Doh? It gets taller and it gets what? Skinnier, right? That's a vertical stretch. Okay, what about a shrink? A shrink is when, let's say you make a castle out of Play-Doh. Okay, and I'm going to shrink your Play-Doh. What I'm going to do is I'm going to take my open palm and smash down your castle, or whatever you built. Okay, whatever your heart desires. What's going to happen to that Play-Doh, as I smash it, it's going to get shorter, and it's also going to get wider, right? Okay, So if I'm stretching this little a, my constant in front of my function, the 8 and the 1/4, if I'm stretching, it has to be a has to be greater than 1. Okay? If I'm shrinking, my a has to be, let's see if I write this correctly, a has to be greater, so it's 0, and less than 1. So what that means is it has to be a fraction. It has to be a fraction in between 0 and 1, like 1/4. 0.25 is in between 0 and 1. Okay, I stick that out in front of my function. I will shrink it. If I want to stretch my function, I times the whole function by something greater than 1. Okay. All right, so next one, reflections. Reflections, the x-axis reflection is this one. I'll do it in red. So if I have an x-axis reflection, this is the x-axis. I'm just going to do a parabola because we all know that. This is just review. I'm flipping it over the x-axis. Okay? Okay, if I had what you do for the x-axis reflection, just a reminder, you put a negative in front of the whole function. Let's say if I gave you a y-axis reflection. Let's do green here. Okay, this is the y-axis. I have a parabola, and I'm going to flip it over to the other side. I'm going to flip it around the y-axis. Okay, now y-axis is a little bit different. I'm going to write this word here. And those of you that have had me before should recognize that word. It's called input. Okay, I'm just going to write it there. I will talk about it when I get up to horizontal translation. Okay, skip it for now. All right, we have vertical translation. That's very, very simple. We add or subtract a k value. Right, a k value could be any number. We add or subtract. If we add, we go up. If we subtract, we go down from the whole function. Okay? So if I have a function of x plus 2, if I want that x plus 2 line to go down, how many units? Let's say we want it to go down 4. I have x plus 2 minus 4. Okay? If I want it to go up 4, I do x plus 2 plus 4. Okay, especially right here. This gives you clear-cut examples. Alright, notice how in a vertical translation there's not a set of parentheses. And we get up to here, we have a set of parentheses. Alright, so if k value is the amount I'm going up and down, the h value is the amount I'm going left or right. Okay, now this is hard. Why is it hard? Because of this right here. If I'm going 2 units left, x plus 2. That's opposite of how our brain thinks. Okay? That's completely opposite of how our brain thinks. If you guys thought, if I told you before this and I said, if you want to move a function left 2 units and I give you the option of making it negative 2 or positive 2, you all would tell me negative 2. Every single one of you. Okay? But it's actually positive. It's opposite. If I want to go right 5 units, then it's x minus 5. It's opposite how your brain thinks. Here's why. Okay? So h value is how many units I'm going left or right. Well, just the h value is what we really care about. So what is my h value here? My h value is actually positive 5. Okay? And that's how you get the positive 5, the x minus, which is before we plug in the h value. The x minus is already there. We plug in our h value, we get x minus 5. Okay, then how do we get the x plus 2 for going 2 units left? Well, here's how. We have h, but h isn't going to be a positive 2. H is going to be a what? It's going to be a negative 2. Because I'm going left. Now, I'm just talking about the h value. It has nothing to do with the x minus out in front. This is by itself. We're just talking about this h value. Okay? So, but how does it turn into an x plus 2? It turns into an x plus 2 like this. If this is my general form, and I know I have an h value of negative 2, it's going to be f of x minus a negative 2, right? Because this is my h value. Okay, well, 2 negatives make a what? They make a positive. Okay, that's how we get to positive 2. That should be a review. Dead giveaway, that's a horizontal translation. It's inside a set of parentheses. Okay, it's attached to the x. Okay, Alright, now I'm going to explain it a little bit differently. This is where this word comes into play. Input. Okay, so if I were to type, I don't know, I have these all binded. I have these keys binded. Let's say I just hit input on my keyboard. Let's say I hit input to pull up. Hopefully I pull up the one I want. Let's say I hit input my keyboard and I pull up that screen. Okay? Then I hit it again and your screen changes, right? So I'm inputting on my keyboard, and what's the output? Well, the output's what you're looking at. You're looking at me right now doing this. Okay, so I input, you see the output. I input, it pulls up, you see the output. It's the same thing with functions, right? But here's the deal. Let me erase all this. Input is actually what is inside next to this fancy looking F. It's our X, right? It's usually our X. So what do? If I want to move, let's say, I have x squared. If I want to move x squared, the function x squared, 2 units to the right, okay, my general form be x, or f of x minus 2, because I'm going right, my h value is positive 2. Here's what would happen. Okay, whatever is next to our function, our f, right? Whatever's inside the parentheses is called the input. This original function is just f of x, okay, where x is my input for this function. Remember, like a keyboard, I type on my input my f of x or my x squared, right? That's what I get back. Here's my keyboard. Here's my screen or your phone or your laptop, whatever you're on right now. Okay, here's my input, and this is my output. For example, just a review, and I think this is very necessary. If I plug f of 2 into that function, what do I get out? Get out 4, right? Because 2 squared. Here's my input, my keyboard, output, the phone, whatever you're watching this on. Okay? Now, let's get this out of here. When we use horizontal translation or move things left to right, however you want to call it, we plug in a different input. What do we plug in? We plug in an x minus 2. So here's my original function, here's my new function. That means everywhere I see an x, my input, I'm now going to put an x minus 2. Okay, so we're substituting in. And remember, when we substitute in for a variable, we always put a set of parentheses, always. Okay, don't ever forget that. Okay. Alright, this is where the y-axis reflection comes into play. This is also an input-output scenario. Notice how you have a different input here to here. Okay, the x-axis reflection, it's just x, right? X is your input. You're not messing with x, you're just putting a negative out in front of the whole function. That has nothing to do with your input. Okay, what about a y-axis reflection? It's different, right? It's attached to this f symbol, the fancy f, inside the parentheses. So what does that mean? Everywhere I see an x in my function, I plug in a negative x. Okay, and you guys are going to see it in examples if your head's spinning. It's okay. I'm just trying to explain this to you. Alright? Input, output. If you think like that, this will not be hard. If you try to memorize rules, it's going to be hard. That's when you start making math really hard. Understand it. Try to understand it. Don't just memorize. Alright, so here we go. 1, 2, 3, 4, 5. Let's do all of them. Okay, we want to describe the transformation of f represented by g. So f is my original function, g is my new function. Okay? So let's take a look. And my first question, we have x to the 4th is my original function, my f. G of x equals x to the fourth. Oh no, my pin variety is low. I think it's been saying that for like 2 months. Okay, g of x equals x to the fourth minus 9 is my second function. You need to tell me what kind of transformation is going on there. Okay, how is my new function different than my old function? Well, my new function has a minus 9 attached to it, right? Do I see any set of parentheses? No. So I can already rule out this one. Do I see a negative out in front of the x? Nope, I can rule out this one. Do I see a number out in front of the x? Nope, I can rule out these two. Do I see set of parentheses? Nope. Okay, what's my only option here? A vertical translation. And that's the process you got to go through, guys. You got to just eliminate it. It means to erase. Okay, eliminate all the ones you don't need. There's certain hints that give it away automatically. No parentheses, no number in front, no negative in front of the x. Okay, so we know it's going to be a vertical translation. But what does the sign mean on the 9? If I have x to the fourth minus 9, x to the fourth minus 4 here, I'm going 4 units down if I have minus 4. So what does the minus 9 tell me? I'm going 9 units down. And you can always put this. That's vertical translation. Okay, so that one's done. That's all we're doing on these. It's like kind of like a puzzle. Put it together. All right, how is your new different than your old? All right, let's go to number 2. Okay, number 2, my old function is x to the fifth, just plain old x to the fifth. My new function is in parentheses. Remember, light bulb, light bulb. Okay, x plus 1 to the fifth plus 2. Okay. Now, let's just take a look. Does this function right here resemble any of the other functions? Well, is there a number in front of the x? No. Is there a negative anywhere in this problem in front of the x? No. Is there a number added or subtracted on the outside of the x? Not attached to it, just on the outside of the parentheses. Yeah, there is, right? What about, is there a set of parentheses and something, a number is attached to the x? Yeah, there is. Okay. Now remember, what is this x minus 5 and what is this x plus 2? How are they different? Well, one's going left and one's going right. I have x plus 1 inside my parentheses here. So which one do you think I'm going to do? Left or right? Well, this is x minus 5 and it goes right. It's obviously going to be x plus 2, 2 units left. I'm going to go 1 unit left. That's going to be my first transformation. Okay, and right, we said it also resembles this. It has a number added or subtracted on the outside of the parentheses. Okay, it has plus 2. We're going to go up 2 units. Done. Okay, not a big deal. Okay, making sense or no? I guess you guys can't tell me. Well, you'll tell me on Schoology Message or something, and we'll zoom and get it figured out. It's no big deal. Okay, let's look at number 3. Our old function is x to the sixth. Our new function is negative 5 times x minus 2 to the sixth in parentheses. Okay, once again, let's talk about our transformations. How does it resemble? Well, do I have a negative out front? I do, right? So we know it's going to have to do with something called some kind of reflection happening. Do I have a number out in front of the x? I do, right? So we know we're going to have to be a vertical stretch or vertical shrink. You should know that by now. Okay, you should know which one it is. Okay, let's do those first. So we have a negative 5 out in front. If any of you are saying you're going to vertical stretch by a factor of negative 5, oh, I'll be very disappointed. That doesn't make no sense, does it? You can't vertical stretch something by negative 5. You can stretch it by 5. Okay, but what does a negative out front mean? Well, the negative out front means, look right here. Is the negative inside the parentheses? No, it's on the outside, right? So cross off this one, and we're going to have a reflection over the x-axis. Okay, Okay, there we go. That's the first one. Okay, what about the 5? What does a 5 tell me? I have a 5 out in front of my x. Well, let's look up here. Okay, stretch by 8 and shrink by 1/4. Remember, I told you the difference. Is a greater than 1 in this case? What's my a value going to be? Well, my a is going to be this 5. Is a greater than 1? Yeah, it is, right? So we're stretching by 5. Vertical stretch by 5. Okay, and now let's do the last one. Okay, we just did one like this. We have a set of parentheses, and we have a number being added or subtracted to x, but it's connected inside the parentheses. Okay, so we know we're going to go left to right. Remember, it's opposite how your brain thinks. It's x minus 2, so we're not going to go left, right? It would be plus 2 if we're going to go left. We're going to go right 2 units. And we're done. That's it. Okay, only 3 of them there. Alright, 4 is very, very easy. Okay, what does a 1/8 out in front tell you? Automatically tells you it's a shrink. Why? Because it's a number out in front of the x and it's between 0 and 1. That means the function is going to get shorter and it's going to get fatter. Okay, like I'm doing at old age. Haha, don't laugh at that. Okay, so we're going to shrink by 1/8. And what does a negative attached to the x in front of the x inside the parentheses tell you? Well, it's kind of the opposite of what we just did. It's here, right? The negative would have to be attached to the 1/8 in order to be an x-axis reflection. Well, it's attached to the x inside the parentheses, so it's a y-axis reflection. I'm just going to start calling them a flip. Like, if you want to, you can say this. Shorthand, I know what you mean. Okay? So y-axis flip. We're going to shrink by 1/8. That's the number out in front. And then a y-axis flip because the negative is on the inside of the parentheses and it's in front of the x. Alright? Gotta practice these. It's the only way we get good at them. Okay, next one. Number 5, we have x minus 10 inside the parentheses. Okay, and we have plus 1 on the outside. Well, the plus 1 is the easy one, right? We know we're going to go up 1 because it's on the outside of the parentheses. What does the minus 10 tell us on the inside of the parentheses attached to the x? So are we going left or right? Well, you got a key right up here. This was x minus 2 and we went right 2. This is x minus 10. We're going to go right 10. Okay? Pretty easy. Not hard. You just got to get it in your brains. Okay, this chart, you got to know it. Don't try to memorize it. Understand it. Okay, if you try to memorize this, you're making math way too hard. Okay, understand what's going on. Okay? Alright, we're going to skip number 6. We're going to save that for the end. Write a rule for G that represents the indicated transformation of the graph of F. Okay, so number 7. Let's knock that one out. Okay, so here's what we want to do. We want to write a rule for G. So this is what it's telling us to do to f of x. Okay, so this is my directions. Alright, to try to get to my destination, like Google Maps. Okay? So, it wants us to attach a negative, right? Attach a negative to the x. Remember what I said. This is the input. Everywhere I see an x, I'm going to put in an x minus, so g of x is going to equal x negative x cubed. Okay, because everywhere I saw an x, I put in a negative x. Bring down the plus 8 from our original function. Then we also have the minus 9, right? Boom. Okay, attach minus 9 to the end. Okay, so let's simplify a little bit more. So we have g of x equals negative x cubed. 8 minus 9 is what? Negative 1. Done. Alright, what do we actually do to the function? Do you know? Let's see. Why not? We got time. So you guys are like, no, we don't. Get us off here. Well, this is part of the understanding process. Okay, so let's close this. Let's go to Google. Let's go to Desmos. You guys love Desmos, I know it. Okay, let's type in our original function, which was f of x equals x cubed plus 8. And let's try to see how they're different. Right, what was our new function? It was, what do we say it was? Negative x cubed minus 1. There it is. Okay. Now, how are they different? So what happened? Is the blue one, is it lower or higher than the red one? Okay. Look right here. This is kind of the point I'm looking for. Look right here. Is the blue one lower or higher than the red one? Well, it's lower, right? We went down. How many units did we go down? Well, we can count. 1, 2, 3, 4, 5, 6, 7, 8, 9. We went 9 units down. Does that make sense? Yeah, it does. That tells us we did. So 9 units down. Now, what is the negative x on the inside of the parentheses? The input. Okay? Everywhere we saw an x, we plugged in a negative x. Well, what does that do? Well, let's just take the x, the negative, off. What happens to it? What are we doing here? Are we reflecting on the x-axis? No, right? That would be this. See the difference? I actually did something cool there. Okay, see the difference? That is the x-axis. This is the y-axis. Can you see the difference? Yeah, a little bit. This function's hard to see. Okay. So it's a y-axis reflection. Why is it a y-axis? Because it's a negative inside the parentheses attached to the x. In front of the x, I should say. Alright, that's how we can tell the difference. I can actually show you with an easy quadratic. Quadratics is so easy to see. Let's just do basic. Oop, not x plus 2, x squared. Basic quadratic, and you can skip ahead if you don't want to watch this. But once again, I'm a nerd. So let's do the same thing we did to this function, and let's do it too. So they're right on top of each other. That's why you only see the blue one. So we went, what do we do in this one? We went down 9. Let me zoom out a little bit so we can see it. We went down 9. Let's use the red one as our original. We went down 9, and we did what? We flipped over the y-axis. Oh, I went it right here. Beautiful. There we go. Does anything happen to a parabola when I flip it over the y-axis? No, right? Because it's what? It's symmetric. Right? It's the same on both sides. So nothing really happens. Okay, but what happens if I flip over the x-axis? If I put the negative out in front, outside of the parentheses. Boom. You see that? We're flipping, not delete. We're flipping over the x-axis. Just pressing the wrong button. Let me zoom out so you can see it better. That's what we're doing. That's the whole point of transformations. Okay? What if I wanted to take this function right 2 units? Well, inside of our parentheses, we needed to go minus 2. I took it right 2 units. Okay? What if I wanted to go 5 units to the left? Plus 5. Okay? That's how that works. It's kind of cool to see it visually. Alright, let's finish these notes, and then we'll be done. It's a shorter lesson today. I'm only at 30 minutes so far. I won't make it to 50 minutes at all. That's a good thing. You guys are probably happy about that. Okay, so number 8. We'll come back to number 6, remember. So number 8, we have f of x equals 2x to the 5th minus x cubed. Okay, a little bit harder here because we got multiple x's, and then we have plus 1. I didn't see that. That kind of blends in. Okay, now g of x, our directions are, so g of x is going to be 5 times f of x. 5 times f of x. Do we know what f of x is? Yeah, we do, right? So I'm going to plug in this whole function for f of x. And what am I going to put around it? I'm going to put a set of parentheses around it, because we are substituting something in. Okay, always put a set of parentheses at it, around it. Okay? So do I want to leave that 5 out there? No. Maybe if I'm lazy, I do. Okay, what do we got to do here? D word. Distribute, right? How many times? 3 times. So we have g of x equals 10x to the 5th minus 5x cubed plus 5. Donezo. Okay, does that make sense? What do we do to the function? Well, we put a number out in front of x, right? Put a number out in front of f of x. We multiplied the function by a number greater than 1. That means we are stretching by 5 units. Okay, you want to see Play-Doh real quick? Watch Play-Doh. Let me get rid of this one. Boom. Red Play-Doh. Okay, this graph is red Play-Doh right now. Watch. So I'm going to stretch. Boom. Crunch it up. Stretch it. 5 units. What's happening to that Play-Doh? As those A values increase, that graph is getting taller and it's getting skinnier. What if I did 100? See how skinny it gets? Boom. Stretch. Right? A is greater than 1. What if I want it to get shorter and fatter? What if I want it to shrink? Okay? Then I multiply by something in between 0 and 1. Okay? Watch it get shorter and fatter. You want to see it get really short and fat? Watch this. Boom. Okay? Now look at our function. See what I mean? If we want it to get taller and skinnier again, all we gotta do is decrease the value it's getting shrunk by. And we're back to normal. Okay? Hopefully that makes more sense. If it doesn't, well, I tried. Alright, back to number 6. Number 6 is kind of a doozy. Okay, why is it a doozy? Well, it's the first type. Let me can I put a white box around this? Boom. Okay, can I fill in that box? Maybe not. Maybe not. It's alright, I tried. Alright, let's erase this. I'll just zoom in really, 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 really small. Okay, here's what I want to do. We have our f of x. Here's my original function. Okay, x cubed minus 6x squared plus 5 cubic. Okay, it's telling me to come up with a new function based on the transformations it's telling me. Well, how many transformations do we have here? We're going 1 unit to the left. Okay, we're going to reflect in the x-axis. And vertical stretch by factor 2. I'm using different colors for a reason. You guys should too. Stay organized on these. These are pretty hard. Okay, if we're going, let's do the first one first. If we're going to do 1 unit to the left, remember, our general form is going to be x minus or x plus. If we're going left, that means our h value is going to be -1. So we have a double negative, which means plus 1. Okay, so we're going to have f of x plus 1. That means everywhere I see an x in my function, I'm going to put a new input my x plus 1. So here's what it turns into. Put parentheses around it because you're substituting in. X plus 1 cubed minus 6 times x plus 1 squared plus 5. Okay, first one done. Now, really notice I put in a new input. X plus 1, I put everywhere I saw an x. Okay, right here, right here, right here, right here, right here. Okay? Alright, now followed by a reflection in the x-axis. Well, what's a general form for an x-axis reflection? Let's look. It's right here. Put a negative out in front of the whole function. So we're going to put a negative out in front of the whole function. And then we're going to distribute. So we have negative x plus 1 cubed. Don't try to put that inside the parentheses. Leave it out front. That turns this negative 6 into a positive 6. Do not try to distribute into the function or inside the parentheses. That's a no-no. And then it's going to be minus 5, not plus 5. Stay organized here. Okay, last but not least, vertical stretch by factor 2. Well, those are easy. You take this whole function and you multiply it by 2. So I'm just going to rewrite my function. Seems like a lot, but when you break it down and do it a ton of times, it's not that hard. Okay? If you have problems, send me an email. You can distribute this and finish this off. I'll leave that for you guys. That's it. That's today's lesson. Shorter than yesterday's, or I guess it was Tuesday's. Not too bad. Okay, your next lesson will be on Monday. I hope you guys have a good weekend. Get that homework into me. Message me if you have questions, especially about this stuff. This is mostly a review. That's why I went kind of quicker than normal. But if you don't think it's review, send me a message and we'll hop on Zoom. Okay? We got all day tomorrow, all day Friday. Everybody good? Okay? Alright. I'll see you guys.